In the previous video, we discussed the introduction to algebra. In this video, we're going to go over how to translate word problems or word questions into algebraic equations. Now, this is not going to be the definitive guide. Rather, I'm going to point out a few common themes that students tend to get wrong. So think of these as important tips rather than a complete method. Okay, and we'll go over one or two questions just so you can see how to apply these tips. So the first tip is when you encounter an English question in words, we want to, such as, let's say this one. So 5 less than half my age is 20 less than a third of 2 less than my age in years. And the question is, what was my age last year? So now, solving this in our heads seems kind of difficult. So what we're going to try to do is translate this into an equation. Now, there are many ways to do that, and so one of my goals today is to give you guys advice not on just how to do it some way, but how to do it efficiently. So to do that, we're going to try to do it parallel. In other words, our translation of this to the math will be as close to parallel or in order to the actual language. So if this says 5, we're generally going to write a 5 first. We're not going to write this 2 first. Now, there's a star here and a star here. There's going to be an exception to that. So we're not always going to do that, but generally we're going to try to keep the math going in parallel with the English. So what is the exception to this rule? The more or less than. So for example, if I say 5 less than, let's say I say that I am 5 years older than Bob. So let's say Bob, so I'm Ilya, so I'm I, and there's Bob. So if I'm 5 years older than Bob, you might say, oh, that's 5 plus B, whatever Bob's age is. Now, I have a huge problem with kids doing this because then when it gets time to say less than, people are going to say, oh, if I'm 5 less than Bob's age, you're going to write 5 minus. And what 5 less than means, it means Bob minus 5. So the order is wrong. In other words, even when you see more, so for example, 5 more than, you might say, oh, it doesn't matter because 5 plus B is the same as B plus 5, but that creates a bad habit. So we're all about creating good habits. So if you, for example, if you wrote I equals 5 plus B and the question had said, Ilya is 5 more than Bob's age, 5 years older, I would mark this wrong just to teach you a lesson to put the 5 afterwards. So again, these are the exceptions, the common exceptions to keeping this in parallel. But generally, we're going to try to translate this into math as we go. So that's the number one rule if you forget everything else. So these two unhappy faces represent the two most common errors, which, like I said, is reversing this minus 5, saying 5 minus B rather than B minus 5. So that's the first unhappy face. And this one deals with the of. So we'll get to this in a second. So then there's, by the way, there's no substitute for just doing a lot of practice. So as you practice and do a lot of word problems, these are the tips you want to keep in mind. So second point is learning your key terms. So when you see Bob is 5 years old, or I am 5 years old, the word is, we would translate as an equal sign. So that might be kind of obvious, but some other words might not be. So as you get used to translating words into symbols, you'll see these connections better and better. So let's say we do something slightly different, which is Bob is half of John's age. So we would say 1/2 times John's age, or we could just say 1/2 J written together. So in this case, the word of means multiplication. So when you see of, it's not just a random English word, it actually means a very technical thing in math. So the sad face indicates that sometimes, such as in this problem, we have a third of, and then after the of, it's not like there's one thing, we have a ton of stuff. So oftentimes after the multiplication sign, we want to open up a huge set of parentheses rather than just writing the thing directly, because if we don't, then whatever happens here, we won't apply the 1/2 to. So we'll see how this works in this problem. So to illustrate the issues with of, let's actually get into this problem. So 5 less than half my age is, right? So we're going to go in order, but the is going to be an equal sign. So 5 less than half my age. So let's say we're going to call my age A. So 5 less than whatever. So there's going to be a minus 5 at the end. And it says half my age. So this should be a 1/2 A. So 1/2 A minus 5, pardon the minus 5 being over there. We'll put it over here. All right. Is 20 less than, so that's going to be something minus 20, a third of. So when we see a third of, it's a third times, and for the of, I'm opening up a huge set of parentheses. 2 less than, notice again, we're not saying 2 minus, 2 less than what? 2 less than my age. So if my age is A, some variable, 2 less than that is minus 2. So here's the point. Notice how we put the set of parentheses. If you don't put these parentheses, then you're just going to take a third of the A instead of the third of the whole thing. So that's this error of not putting parentheses when you have a phrase in English that has a huge of phrase. Okay, and at this point we would solve this. So let's just solve this just to see how this would run. We can solve this a number of ways. We can multiply the 1/3 by the A, and then the 1/3 by the -2, and group terms. I'm going to solve it in a slightly different way because I don't like fractions. So we're going to get rid of this 2 and the 3. How are we going to do that? The least common multiple of 2 and 3 is 6. So we're going to multiply everything by 6. That's going to wipe out all the fractions. So 6 times 1/2 is 3. So this is going to turn into 3A. But the 6 is spreading to everything, so that's going to be minus 30. Then on this side, the 6 over 3 is going to be 2. So therefore that 2 is going to double the A, so that's 2A. So we're doing a few steps in one here. 2A, and then times -2 is -4. So the 6 over 3 turned into a 2. 2 times A is 2A. 2 times -2 is -4. And then that 6 is also spreading here, so that's a minus 120. All right, now we can move this A over, these 2A over. So we have A left, move the 30 there. So we have -124 on the right. If we add 30, we're going to have -94. All right, so that's what we got, if I've done this correctly. And there's a few things to keep in mind here. First of all, we're not done because the question didn't ask for my age or our age right now. It asked for the age last year. So a year earlier would be -95. The second point is, if you're sort of scratching your head, how can an age be negative? You're absolutely right. So this problem was purposefully poorly designed so that we get a negative number. But oftentimes when you're solving algebra, you'll make a mistake and get some wacky answer. Ages can't be negative unless this is 94 years before you were born. So you always want to make sure that your answer actually makes sense. So in this case, the problem is wacky and bad. But normally when you get something like this should be a warning sign that either there's a mistake in the problem or there's a mistake in your work. All right, so that's an example of using some of these concepts. Now, in terms of difference of, that can be ambiguous. So if I say there's X and Y, and we want to take the difference of these two numbers or two ages, that could indicate this or that. So we don't know what order it is. So sometimes you have to be careful in how you set it up or what you can even assume in setting it up.